Here's what you missed on chemistry.
We thought we could make ferrofluid by burning steel wool because it's a magnetic alloy.
We burned a whole lot of steel wool.
Look at all that fiery steel wool!
Then, we almost made our arms fall off by grating the magnetite, Fe3O4, off the burnt steel wool.
Can you guess how much we made? Over 70 grams!
Look at all that magnetite.
Wow!
Then we mixed that with a whole lot of canola oil to make an aqueous solution.
But then it didn't work, so we went back to the drawing board and came up with a real science experiment.
And that's what you missed on
Chemistry!
Safety precautions for this lab: wear goggles, wear gloves, and use the fume hood.
In order to make our real ferrofluid, we need iron 3 chloride and iron 2 chloride.
We need the two iron isotopes to make Fe3O4, meaning we need two irons with different charges.
Here we're measuring out
2.4
grams of iron 3 chloride.
We measured out 200 milliliters of water.
Then we mix those together really well.
Next, we measured out 25.3 grams of iron 2 chloride.
We also measured out 100 milliliters of distilled water.
Then, we mixed the solid into the water, creating an aqueous solution.
Here are the two solutions: iron 2 chloride's bright green and iron 3 chloride's dark orange.
Next, we needed ammonium hydroxide.
This is very toxic and can only be used under the fume hood.
We measured out 4.73 milliliters.
We put that in a volumetric flask and added water until it reached the 100 milliliter mark so that it became 0.7 molar.
Then we took 1 milliliter of the 2 molar iron 2 chloride
and 4 milliliters of the 1 molar iron 3 chloride.
We mixed the two together with a magnetic stirrer as we slowly added the ammonium hydroxide.
We added a little bit of the 50 milliliters at a time, and each addition made the solution turn darker.
This reaction is synthesizing a precipitate that occurs when you mix the three solutions.
The precipitate created will be magnetite, Fe3O4.
After the solution was mixed for 5 minutes, it sat for 10, and the precipitate separated from the liquid.
We then decanted the excess liquid until we were left with the magnetic solid, magnetite.
We washed the solid multiple times until we had a clean sample of Fe3O4.
Next, we measured out 2 milliliters of oleic acid.
Oleic acid is a surfactant, which is used to form a shell around each magnetite particle so that the magnetite is stabilized and the particles are separated, which prevents clumping.
The attraction between the magnetite particles is weak enough that the surfactant's van der Waals forces were enough to prevent clumping.
So what does this have to do with
chemistry?
This is an example of a precipitate reaction. Iron 3 chloride plus iron 2 chloride plus ammonium hydroxide yields iron 2,3 oxide and ammonium chloride. This was the liquid we decanted. The Fe3O4 is the precipitate.
The ferrofluid itself is a ligand reaction, meaning the oleic acid molecules are attracted to the magnetite with covalent bonds.
Additionally, ferrofluid is superparamagnetic, meaning it doesn't stay magnetized when removed from a magnetic field. That is why it is a liquid when it is not near a magnet, but can form shapes when it is.
We also mentioned van der Waals forces, which connect to chemistry since they are intermolecular forces that deal with attraction between molecules. The oleic acid's van der Waals forces prevent clumping in the solution.
In our original experiment with the burnt steel wool, the same phenomenon happened. When the steel wool burned, it left iron residue. The iron particles were then mixed with canola oil, the surfactant.
This solution was much more concentrated, more iron, so it formed bigger peaks. If we had a larger quantity of the Fe3O4, then we could have made similar peaks in the second experiment. These two experiments really tested our patience, but we're happy we stuck with it and made two cool ferrofluid solutions.
But next time we're buying it from the store.
Catch you
Next time on
Chemistry.
The same phenomenon happened.